Welcome to our fourth library webinar. In this one, we are going to explore how we can get people ready for 21st century jobs by developing certain hard and soft skills. We're going to use the example of engineering and advanced manufacturing and look at some role play that you can do. It's really fun. And also our 3D modeling course and the job skills poster, which you can use as a tool in your library. I'm Sheila Bunch. I'm the Director of Education for NCLab, and this webinar series is made possible by a Nevada State Library Archives and Public Records Continuing Education grant funded by the Institute for Museum and Library Services through the Library Services and Technology Act. For those of you who don't know, NCLab is a self-contained desktop platform where you can learn and use computer programming, modeling, and many other STEM skills. Of course, STEM stands for science, technology, engineering, math. And the way we set it up is that you learn through self-paced, self-graded courses. Then you apply the skills using our apps in Creative Suite. We'll be looking at one of those today. And one emphasis today is reinforcing those skills with projects, including social interactions. This is what we're learning today. I'm going to introduce you to our job skills chart, and all libraries will be getting a copy of this within the month. This is going to be a huge poster, so it'd be nice to put up in your library and give people an idea of what's out there. And from that job skills chart, we'll be identifying skills to practice. And then the other big piece that we're going to look at is the engineering cycle itself and how it's used to design solutions to problems. We're going to design solutions through what we call client-designer role-playing partnerships and also through 3D modeling. And then look at how we can set up learning cycles that increase complexity, technology, and relevance. Some nice big $60 words, as I used to tell my students. Okay, so here's a picture of the chart. And you can't see it, and that's okay, but you can get an idea of the scale of the chart. And I'll walk you through the main points in this slide presentation. So what the chart does is we've really distilled which skills are in demand and then how we can mesh those with what we're doing at NCLab so that we can provide those entry points for people. Okay, here's the big word here, digitalization. Let me say that again, digitalization. Businesses are transforming themselves through digital technology and information to improve efficiency, which is doing things right, and effectiveness, which is doing the right thing, often mixed up. So what's the impact on the job market? Well, we're all a little bit worried about automation, and it's not just assembly line jobs anymore, but it's amazing how many functions we never considered that could be automated in the past. They can be automated now. So it's something you sort of look over your shoulder at, and you also find yourself doing it. You find ways to improve your own effectiveness by automating parts of your own job. The flip side to that is technology is also creating new job types. So as some are disappearing, others are coming in. And regardless of what job you have, just about all jobs require some digital and technological skills. So even if they're traditional, what would be thought of as manual labor or low skills type labor, they have a technological component. Whether you're driving a haul pack truck at a mine or doing one of the trades, and there's certainly nothing unskilled about a trade. Traditionally, it always took at least 5 to 7 years before anyone took you seriously in your trade. These trades are not unskilled, but they're being affected by technology. Long story short, this is what happens in the chart itself. We look at the phenomena of digitalization and automation, and then we looked at how that impacts jobs. And from that, we really distilled out the STEM jobs. STEM jobs are a problem, and again, that's science, technology, engineering, math, in that not enough people develop the skills to begin with, and out of the people who commit to developing those skills, only a tiny percentage of them actually graduate with, say, a 4-year degree in one of those fields and then apply it. So there's a high demand and there's a low number of people coming in who are qualified. Out of those STEM jobs, we've broken it down into career groups. And the one we're going to look at today is in engineering and advanced manufacturing. They go hand in hand. And we pull out the key digital skills required for success in STEM fields and see how they mesh with our NCLab course plan. So that's how the chart works. We further divide it into what we call hard skills and soft skills. And there are a lot of ways of defining these, but these are pulled from some pretty good papers on the subject. And over in the hard skills, we're looking at what we can develop with our courses. And number one is algorithmic and computational thinking. And you've probably already seen how that starts with Carol. That's a big focus of Carol, is getting that way of problem solving embedded. And then in general, we're looking at problem solving within the digital environment, planning, logical analysis of information. You can think of that as sense making. Now, this is something that's not just being done by people, it's also being done by machines. Programming languages, of course, and engineering design, computer-aided design, and that's what we're going to focus on today. In the soft skills column, we have virtual collaboration. So these are all people skills, but they have that added component of something digital. I'm virtually doing a webinar right now, which I will convert to a YouTube video, which you'll be able to access at any time. And then we have our community where we can discuss things back and forth. So we use those tools. Then the second skill is novel and adaptive thinking. And in the old days, you could come up with a solution and you could live with it for a long time. It had some staying power. You could tool up your plant and keep producing that item or some very similar version of it for a long time. That's changed in industry. Your design parameters change constantly. Then there's this issue of cognitive load management. Well, we're in a sea of information, and I think we all experience it from time to time. We get distracted by information coming from multiple sources, not necessarily related to our task, but also the sheer volume of data and information, even when it's narrowed down to a particular task, it requires management. Multitasking, that's the doing end of that. We're expected to do a lot of things. We have tools at our disposal that allow us to do so. We often have 20 tabs open on our computer, and we have all kinds of apps notifying us so that we are able to do multitasking to some degree. But also, we're looking at how you do that effectively. We know that a person's brain doesn't truly multitask. It can segment tasks so you can jump from task to task, but you can't truly multitask. So what can we do to do this effectively? And one of the answers, of course, is you do it collectively. You do it as a group as opposed to an individual. Resilience is just a combination of stamina and decision-making tools so that you can get through all this. You do need to be detailed-oriented. It's very easy to let details slip out that can have a large impact, because once you hand off a task to automation, for example, most automated systems can't detect an error. They will just incorporate that error. Now that's changing with machine learning. and smart systems, but you still have to really pay attention to details, and this is in direct competition with all these other items above, which tend to work against being detail-oriented. And then visual spatial reasoning. This is a skill that you're going to need in engineering and in advanced manufacturing. You're working with three-dimensional systems and objects, and you have to be able to see how they work together. So now I'm looking at a portion of the chart, which refers to engineering and advanced manufacturing jobs. And we did an initial map of what parts of our courses address these hard and soft skills. Now, from your viewpoint, you're just going to see a bunch of blue boxes and orange boxes and some light colored boxes, which pertain to the course and the projects. But you get the idea of what we're doing right now with what we have and what we're going to develop to address all these skills. So this is zooming in a little bit. And when you get this presentation, you'll be able to read some of these items. Again, the blue skills are the hard skills and the orange skills are the soft skills. All right, so I've pulled out 6 of these, 3 hard and 3 soft. And we're going to develop them through 3 sets of tools. The first one is client designer role play. And this is going to lead us to virtual collaboration and to novel and adaptive thinking. The second part is really understanding how the engineering design process works and following it. It's a way to problem solve in the digital environment, and it's a way to make sense of information. It's logical. And then the third component is our 3D modeling course. So this is going to develop computer-aided design ability and your visual spatial reasoning. So those are hard and soft components that work together. Let's start with this client designer role play. I have to say this is one of the most fun things I ever did. We had one of these sessions here at the Innovation Center last fall. And what I'm showing you today is really based on that experience, and I have to thank the people at Innovations for putting it on and introducing me to this process. This is all about communication, and one of the best ways to develop communication skills is by role playing. I recommend that you start this face-to-face and then apply it to online settings. We still are animals, human animals, and I think we communicate non-verbally as well as verbally when we're face-to-face. It's a much richer setting, and it's also an important one for overcoming anxiety. One thing I've noticed is, especially with young people, is they're becoming mute. They're texting each other. They're not looking up from their devices, and there's lots of jokes about that, but they're missing out on cues and they're missing out on the ability to have a conversation. So we do want to keep that low-tech version in play and help them develop those skills. Then they can apply them to online settings more effectively. So this is a big point. Many problems are solved by observing, listening to, and collaborating with, in this case, a client, but really it can be your colleague, it can be your boss, it can be someone who works for you, it can be a consultant. This is the receiving end of information. We tend to be very good at projecting our ideas, but not so much listening to others and incorporating them into a solution. The engineering process, of course, these are the 2 hard skills we're going to look at. And the main thing is that it's systematic. You do step A, step B, step C, and just like the scientific method when you're trying to understand how something works, this is the analog for problem solving. And we're going to use technology to generate, select, and test solutions. And one thing technology does very well is allow you to use a huge amount of data. And sometimes people refer to this as big data. This leads to precision. Now, precise doesn't always mean accurate, but we can really hone down our final decisions based on the data. It helps with quality control, it helps with tighter inventory flow, and this is the basis for machine learning, which we're transferring a lot of these decision-making capabilities to our machine systems. Then 3D modeling, and that's a good combination of a hard and a soft skill. Something that is important to share with your participants is that it really is an advanced applied skill. They're not going to learn it overnight. They're going to have to train, they're going to have to practice, and that is why we do offer a full course and several projects. The hope is that people learning these skills then create their own. One of the advantages of a CAD system like this is that once you've generated a design, you can test it as a prototype, and this is where 3D printing comes in. This is not going to be how you produce your run-of-the-mill production, but it allows you to test your model physically, and then it makes it very easy to modify it. There are people in the building who work with labware, for example, and sometimes it's a matter of shaving less than a millimeter off their prototype to make it meet spec. So they can rapidly change design through this process. A model that you look at on the screen, it can be viewed from many angles. You can slice it, you can rotate it, you can zoom it. And this ability to see a model in these different perspectives and use the information to solve problems, that's what's going to develop the visual spatial reasoning. One example I can think of is in hospitals, we use an awful lot of imaging these days. And it's amazing when you watch a technician look at whatever they just scanned from you. And there's, slicing back and forth, and they're looking at it from different angles, and that's exactly what they're doing. They're trying to determine, or usually they're looking for abnormalities, and they may measure them right there on their computer screen. They have to know what they're looking at, and they also have to know, when you look at it from a different point of view, how that relates to the other point of view you just used. About 5 years ago, the new science standards were developed. They're known as the next generation science standards. And they embedded the engineering design process in the curriculum all the way from kindergarten through 12th grade, because they recognized how important this is. So schools are slowly incorporating this into their curriculum, but these are often best practiced in an out-of-school environment because they're project intensive. They usually take up too much time during the academic day. So many schools have after, before, or lunchtime programs that help address that. And of course, in libraries or clubs or camps, these are great venues for practicing these skills. So the design component's been integrated, and that's important because you can't just create technology. You want this problem-solving piece. They break it down into 3 steps. So step 1 is that they define and delimit engineering problems, and these are the kind of vocabulary words you want to use with your participants. At the end of the day, once you've figured out what it is you're going to work on, you have to be able to state it as clearly as possible in terms of criteria for success and your constraints or limits. The second stage is that you start designing your solutions. So you start by generating a number of different possible solutions. A lot of people refer to this as whiteboarding. That's when you're just scribbling ideas up on a whiteboard. And then you evaluate potential solutions to see which ones best meet your criteria and constraints that are in A. Once you have narrowed it down, then you're going to optimize those solutions. And in the standards, the way they're written, they really recommend that students choose more than one solution to try out, because then they go through the exercise of comparing pros and cons. So they're going to systematically test and refine solutions and then improve the final design by trading off less important features for those that are more important. And sometimes that's really tough. We fall in love with some aspect of our design. It's just wonderful, but really it may be something that needs to be discarded in favor of another feature. All right, so this is probably a little hard to read again from your end of it, but when you have the slideshow, you'll be able to see it more clearly. What I wanted to compare was how NGSS addresses these three areas, the ABCs, at the K2 end of the band, and then at the senior high school, well, the high school level, I should say, from 9 to 12. So when you're a young student, and honestly, it doesn't matter whether it's a student or an adult human. These kindergarten and standards are really the context for everything we do. So it reminds me of that book, Everything I Know I Learned in Kindergarten. Well, this is sort of the case here. So by they're defining situations that people want to change as problems that can be solved through engineering. And then they can go through this optimizing process where they're comparing solutions, testing them and evaluating them, and developing solutions. And this is a communication piece again. It says convey possible solutions through visual or physical representations. And you can see those are all linked together. This is a back and forth process. By the time they hit the upper grades, they're going to attend to a broad range of considerations in criteria and constraints for problems of social and global significance. So we're going a long way from designing something that has personal or significance to something that has impact on society as a whole. And again, they're looking at optimizing criteria, but now they're using words like prioritize and considering trade-offs, and also assessing what you might think of as side effects, social and environmental impacts as the complex solution is tested. So if I design something for my manufacturing plant, I have to think about these other concerns as well, the social and environmental impacts of what I'm doing. Developing a solution, this is taking now problems that are usually very large and breaking them into smaller problems that can be solved separately. This is a tendency that you'll often find is people will bite off too big a chunk, and really you need to subdivide it, and that again is where teamwork comes in. Okay, so in a nutshell, our problem solving steps, we need to identify the problems, break them into solvable steps, identify multiple solutions, and we can use 3D modeling to design our solutions. In this particular case, we're going to evaluate them and then refine our final design and solution. So this is what we're going to keep in mind no matter what the exercise we're doing. This is best done with groups. Certainly you can do this as an individual, but if you want to develop that communication and collaboration piece, you should be developing partnerships and teams. Now in the role playing, and this is what's fun, when you have partners being clients and designers, they get to be both. So if you're the designer, your partner B is your client, and for partner B, you are their client and they're the designer. So it's a very energized, dynamic process. So you want to try this initially with a very simple and personal project. So now you're thinking K-2, and then migrate it to a project that requires more collaboration and deeper decision making. So now we're going towards the 9 to 12 end of the spectrum. Again, I recommend you start with simple partnerships and offline communication and move towards evolving sophisticated design teams using digital communication. Okay, so this is the exercise itself. This is challenge number 1. We are going to start with something useful and personal, such as a treasure box for younger children. Say a cell phone case with extra features. This might appeal to teens. A wallet that's a little more adult. Certainly as adults, we have to keep our stuff with us as we go around. Maybe even a multi-tool like a Swiss Army knife, which you can model out of cardboard. And here's the process. So we start with an interview, then we do a design sketch, we create a proposal, we execute a prototype for the approved design, present the design, and make notes for design changes. And then you can have a reflection session at the end where people sort of think about how the process worked. You can do this in about 90 minutes. Usually people really get into the building part, the rapid prototyping part, and that takes a bit of time. So materials, you're going to need a set of instructions for the participants because you are outlining a process. It's hard to keep all those steps in your head. You will have simple materials at each pair's work table, and that's just pencil, paper, and ruler for initial design. Then you'll have a supply table, and this can be whatever you have. This is very creative. It could be paper, cardstock. You're going to have things to stick things together. You're going to have some decorative touches. Now, cautionary note on decorative touches, you may want to keep that as a separate reward activity because what you don't want is someone just foo-fooing up their creation without addressing the underlying design concerns. Get the design done first, and then if they want to pretty it up, that's something they can do as an art piece afterward. So the interview. Now, this is something I found fascinating when I did this one myself, is when you interview your client as a designer, you're asking the client about their life. Okay, you're not asking, what do you want in a cell phone case or a wallet? You're saying, what's your life like? And you learn an incredible amount of information this way, plus you bond a little bit. I gave some examples of what's going to build your criteria and constraints. So maybe this person really likes to go hiking and camping. One of the criteria is going to be that it has to be lightweight, and another one is going to have to be rugged, and it's probably a good idea to make it waterproof. Maybe they work in a law office. Well, they might need something that looks the part. They're dressed in a suit and with nice shoes, and they need something that doesn't bulge. Maybe it's made of fine leather, it's got quality finish. So that would be some criteria that you might look at when if someone works in a law office. Maybe they're around small children. Well, you might look at child-resistant features. Maybe they just are crazy about Nevada, so you might think about designing something with a battle-born crest or something on as a decoration. Just getting to know them as a person is going to really pull up a lot of criteria and constraints that'll help you with your design. So then you go away and you've interviewed each other, and now you're coming up with a sketch. Now, this is not a beautiful model on the computer yet. This is just a sketch. And this is the famous napkin sketch that has generated many a company or large project. You're just kind of getting an idea of what it looks like. So here we've got this box. We've got approximate dimensions, about 6 inches tall and 3 inches wide and half an inch deep. We're going to put a little map of Nevada on it in blue with some gold lettering about Battle Born. We're going to make sure it has rounded corners so when it gets dropped, it doesn't break. And hey, we're going high dollar here. This is going to be a carbon fiber case with a rubber seal. It's got a hinge back so you can take your phone out or your items out of it. What we've done is we've designed it to meet lifestyle criteria. We're solving some problems for the client. And hopefully we're going to come up with some different designs that might prioritize different characteristics. And we're already thinking dimensions. It's not perfect, but you want to get an idea of scale. Okay, so now that you've had your little sketch festival, you're going to sit down with your client and you're going to present your sketch to the client, describe the features, and they're going to give you feedback. And they may say, oh, yeah, this is something that's exactly what I was looking for. You know, I don't think I want to spend the money on carbon fiber. Can we just make it out of plastic? So you can make notes on your sketch. You agree on an approved design, and this is still at the prototype stage. But we have something we're going to go forward with. And again, hopefully more than one option, so you can try out different solutions. Well, then you get to make the prototype, and this is really fun. You have people running back and forth to the supply table. Don't be overly generous with supplies, because one of the biggest restrictions with engineering is you don't always get what you would like. It's either too expensive or not available, or it turns out it's not the right material. So I have a range of materials on the supply table, but people might have to agree that someone else has got that, and they can't get it. And of course, it's fun to pretend. So people could pretend, for instance, that duct tape is fine leather. This is strictly prototyping. Once you've built the prototype, and you make that time limited, it's not going to be perfect. You're going to present it to the client. So again, you're presenting to each other, and then you're going to evaluate it, and then you're going to make a list of changes, because it's not going to come out perfectly the first time. Write down what you think you're going to change. That's your first challenge, and those are really fun. And again, you start with something simple and personal. You're developing communication skills, and eventually you can go into teams. You can subdivide the task, but that gets the idea of the engineering process. So now we're going to switch gears. We're going to go to learning computer-aided design. Again, this is something that's we're going to require a huge investment. So let's find ways we can get them started. Don't get too carried away. Again, they got to be super simple. They may simply be designing, for example, a box to begin with. And I've listed some entry points here. They could use the app in Plasm, and I've made a little video. I'm not going to show it today, but you'll have the link. So this is something that we've done many times, is walk people through that app. And I'm going to show that to you. Let's see, oh, here we go. Okay, so if I go to my desktop, I'll show you what I mean. Okay, so if we open this, then you go to 3D modeling and Plasm, you'll see some code. And this is what we call the default app. And it makes a cube that's hollowed by cylinders. And this is one that we walk through step by step. You can run it and just see what it produces. And what I've done is I've created a little video. Go back to present mode, get my pointer going again. And again, I'll give you the link so you can simply show this video, pause it every now and then so that your participants can try writing the code as they go. And hopefully you'll get a chance to watch this. What that exercise does is it really develops a feel for what a program does to adjust dimensions and position and color, and how the commands work, how object-oriented programming works. And like I said, please try it. I think you'll like it. Okay, so the other component, and we've done this in camps, and we've mentioned this before with the Let's Build a Drone project, try and get them at least through Unit 1 in 3D modeling. By the end of that unit, they're comfortable with working with 2D objects and multiple objects. So this is a good start, and then they can, once they've got through this, they're usually game for going on to the rest of it. They do get this nice certificate every time they complete a unit, and we've redesigned those so they're a little more professional looking. This is something that even an adult could show to an employer, and it would make some sense. It's not kids' cartoons anymore. Once they've learned something in the course, then they can try a project. And we have a project for every section in the course. They're thematic, so this can be done as again, as a group activity, and it's fun to compare results. And they're designed so they can be creative with the skills that have been learned up to that point in the course. So the first project is simply a color bar, and you could think of this as a flag, but really they're just practicing developing different colors and putting three shapes together. And then the second project is developing a quilting block. And again, this is using the skills learned in section 2. Section 3 is a shadow box. Section 4 is a castle, and section 5, now they should be pretty comfortable with moving more complex shapes around, and this is to build a piece of jewelry. And this might be the one that you extrude and print out on a 3D printer as a fun token at the end of the course. So that's the procedure. You go through that designer client exercise, a chunk of the course, work on a project from the course, and then loop back, try it again. And each time you loop back, you can increase complexity. Just keep in mind that when you're looking at a new and difficult concept, really make the exercises very simple. It's too much for the brain to try and do difficult and complex at the same time. But once they've mastered some skills, they should start trying to combine those skills and commit to solving a more complex problem. We're also going to increase the use of technology. For example, we're going to start using online tools rather than strictly face-to-face. And you can practice this in the same room. They could be at 2 different computers and using a headset with one of the free online meeting tools and trying to duplicate that relationship through online media. That's just an example. There's so many tools out there. Maybe they're going to start submitting their designs via email or collaborating using an online shared document. And then the third arm of that is to increase the relevance. So we're moving from personal relevance, which is a nice, comfortable starting point, to designing solutions for industry, the environment, and other application. These are the big problems, and this is where you start making your portfolio pieces when you're looking for one of those nice STEM jobs. Okay, so just some tips on managing partnerships and teams. Start with the comfort zone. They may be similar ages or have similar interests, and certainly ability levels is a consideration. Partnerships are most effective when the ability level is fairly close. In education, this is referred to as the zone of proximal development, big fancy term, developed by Vygotsky. Something to be careful about. Try to avoid putting an expert together with a novice for a working partnership. This is okay for mentoring, but it tends to be a little too uneven when it comes to working as partners. And people who are closer in ability together get much more out of the exercise than if they're too far apart. Okay, so structure your time frames and outcomes so that everyone participates, has responsibilities, and meets deadlines. Those are the skills of the work world. And if you have some non-negotiable rules, post them and always review them at the beginning and end of any session that you're working with your participants. And that doesn't matter if they're kids or adults. This is something that's a good habit to get into. Okay, so having just said all that serious stuff, remember these are game-based and they should feel safe and they should be enjoyable. We're not stressing that we're producing something that's going to go on the assembly line next week. We're trying stuff out. Okay, so beyond partnerships, once you start getting into a larger team, you might consider assigning roles. This again fits with workforce development. You might have someone who's the scheduler. They keep pace and keep everybody mindful of deadlines. You can have an instructor who does all the reading, essentially, making sure all the team members understand the requirements. You can have someone who's quality control and they're checking outcomes. Have we followed the process? Have we done what we said we're going to? Are we meeting our criteria and constraints? And then if you have a good writer, they can be the one who documents everything. And all, again, these are all real world skills and good job training. Another way to assign roles is our what we call SMEs, subject matter experts. And we talked about STEM. In education, nobody wants to feel left out. So STEM becomes STEAM, and then STEM becomes STREAM. And that breaks down to scientist, technologist, reader, in other words, the language expert, the engineer, the artist, and the mathematician. So again, you can start with people's strengths. So that's your existing expertise. Once they're comfortable, it's really good for them to try on a role that's unfamiliar. Again, this is a safe setting for trying on unfamiliar roles. It builds confidence even if they end up with a mess. And you never know, they might uncover some talents they don't realize they have. So summing this up, we learned a little bit about the job skills chart, which you will be receiving. We learned a bit about the engineering cycle, how to use the client designer role play exercise, and ways to get them into 3D modeling. Also, how to set up learning cycles where you're going to spiral up through complexity, technology, and relevance. We do invite you to join the community. Everything gets posted there. So you get this slideshow, you get a copy of the webinar, you get any materials that go with it. For example, there'll be a worksheet that goes with this that you can print out for your participants, gives them instructions on one side and a place to write on the other. And the little video where you can introduce 3D modeling by exploring the 3D modeling default app. So do you have any questions? Okay, thanks, Matt. And yeah, try these out. It's always a little clunky the first time you do these things, but once you get a little experience with those kind of social exercises, they really are a lot of fun, and it helps make that transition from us good old animal humans to our some more cyborg selves. We're definitely married to technology these days. All right, well, good wishes to everyone, and we'll have another webinar in 2 weeks, and I will get all this stuff posted on the community page by tomorrow. So I hope you're all surviving spring breaks. I know that's always a busy time for libraries, and hopefully enjoying some nice weather for a change.